Welcome everyone. In this video lecture, we will discuss the difference between the operational amplifier, that is our op-amp, and a amplifier. So basically, an amplifier circuit have some output, input, and some amplifier gain. So in case of amplifier, the output voltage, that is our V naught, is A times of Vi. So what it means, we can directly say the output voltage is directly proportional to the input, and A is a proportionality constant. So V naught equals to A times of Vi. But in case of operational amplifier, if I am saying this one is having voltage V naught, output voltage V naught, and this one is the equivalent circuit of a op-amp. Okay, it may be our LM741 op-amp. Okay, so in this case, the output voltage V naught is A times, okay, V2 minus V1. Okay, this one is a V2 minus V1. The difference between these two voltage across the non-inverting in and inverting in. So this one is the one of the difference we can say. In addition to that, the in case of amplifier have a number of flip sides or shortcomings, or here I am writing shortcomings in comparison to the op-amp, or we can say the flip side. Okay, some this factor. Okay, so the first thing, in case of op-amp, it has what we can say, it has low input impedance. Okay, but our this one having the very high input impedance. So this one having the low input impedance. Okay, on the other hand, it have a very high input impedance. For a practical op-amp circuit, if it has infinite input impedance, or for the ideal one, it has infinite input impedance. Okay, so that's why the current through the inverting in and non-inverting terminal will be zero. Okay, the I1 and I2 will be zero. So this one is the first one. We can say the difference, the input impedance is low in case of amplifier, traditional amplifier, and in case of a open based circuitry, it is a very high input impedance. Okay, in addition to that, it has a moderate gain. Okay, so this one I am writing shortcomings in comparison to this flip side. So but this have a high gain amplifier, or sometimes it is say differential amplifier, high gain differential amplifier, because the output function V naught is a function of a V2 minus P1. So that's why this one is also called the differential amplifier. Differential amplifier. Okay, so this is basically the shortcomings or flip side of this op-amp, but op-amp is more convenient. Okay, so this one is the second one. Okay, so now for the third one. Okay, so the third one, we can say, in in case of amplifier, it have a very limited bandwidth. Okay, in case of op-amp, the bandwidth will be more. So but in case of this one having the limited bandwidth, so bandwidth will be always more in case of op-amp. Okay, so it has infinite bandwidth in ideal case. Okay, bandwidth. Okay, ideally, but it has some limited bandwidth. So this one is the third one. Okay, and the other one, that is our very important one. So I am writing with some different color. Means in case of amplifier, it amplify either environmental, it amplify environmental mental noise. Sometimes it also amplify thermal noise, or in general we can say any other noise signal present input in the input. But in case of op amp circuit does not amplify environmental noise, thermal noise, because this one is a differential amplifier. So the this one will be subtracted or cancel out due to this V2 minus V1. Okay, or any other noise signal present in the input. So this one is also very important point, that what is the difference. So the difference is, in amplifier it may amplify the noise, thermal noise or environmental noise or any other noise signal present in the input, but op amp restrict these noise. So that's why this op amp is also very much useful. Okay, in addition to that, uh, it has common mode rejection ratio is infinite. So I am not writing, but this has a zero common mode rejection ratio. Okay, because if both the inputs V1 V2 are same, say V1 V2 1 volt, so the output voltage will be simply V2 minus V1, so it should be 0. So if the common inputs will be there, so it will give the 0 value. But in case of this, it did not happen. But in general, this an application point, applications, applications. So basically, amplifier is also used in various things. Okay, and it is widely used in modern. Even this kind of amplifier also used in modern communication system or instrumentation system, etc. So instrumentation system, in instrumentation, okay, modern communication system, and this can be used also in the communication, like we can say analog computation. Okay, means summer circuit, integrator circuit, summers circuit, integrator circuit, differentiator circuit, logarithmic amplifier, I'm not writing, and even sophisticated instrumentation also. Sophisticated instrumentation also. Okay, so these are the some few points that we have to remember. Means basic difference means the input impedance will be very low, but in case of this one, high input impedance, moderate gain, but it has a very high gain amplifier, high gain differential amplifier, we can say high gain differential amplifier. Limited bandwidth, it has infinite bandwidth. The major one is this one. Okay, it it may amplify the noise signal. Okay, but this open based circuitry does not amplify the noise signal. So this is all about the simple difference. So this one is a block diagram and this was the equivalent circuit. So this one is our inverting terminal. Okay. So I am supposing that everyone knows this one is inverting terminal. Okay. And non-inverting in non-inverting inverting terminal. Okay. So this one is the some fundamental what we can say the difference between operational amplifier. So thank you for watching this video.